All right, let's tackle this last set right here, these 6 problems that are staring me in the face. It starts as a logarithm. Let's turn it to an exponent. X squared equals 144. And then I grab my calculator. No, I don't, right? Okay, think about this logically. Something squared gives me 144. Now, if you want to get all technical, the best way to solve it is to square root. Now, here's where things get really fun. Square root of 144 is 12. In the process of solving, you always consider positives and negatives, okay? I would love to grab my pen here and be like, plus or minus. That's fantastic. Good luck with that. Good luck with having a negative 12. Let's try it. So let's suppose I do plus 12 and minus 12. Then I would say log base 12 of 144 is 2. That's lovely. I would also be saying that log base negative 12 of 144 should give me 2. Oh my word, what has happened? We have just delved into the realm of imaginary numbers. Love them, they're great, they do exist, they're misnamed. They're not imaginary. I don't know who named them that, but they shouldn't have. Anyway, but they don't work with logarithms in this case. You can't take the log of a negative number if you want to keep it real, so to speak. Okay, let's move to the next problem. Our gut reaction at this point is to rearrange and be like, oh man, this is great. I've gotten in such a habit of this. I'm going to go 2 to the x equals 32. Fine, do that. You're not wrong. But actually, everything you need is right here. Right here. X equals that. I said right here and just pointed at the whole thing. The whole thing, though, it's equal to x. So log base 2 of 32, which we can kind of figure out in our head. A logarithm is a question that says 2 to what power gives me 32? 5. 2 to the 5. 2 to the 5. I better get 32. There we go. 5. X was already isolated in this case. So up until this point in this lesson, I've been saying, or in this set of problems, I've been saying, okay, if it's exponential, turn it to a log. If it's log, turn it to an exponent. This is an exception because X is already by itself. All right, next one. Here we go. X to the 7 equals 2187. How do we undo? Oh my word, that's a mess. Same way we undid this one. We square rooted to get rid of a squared. Let's 7th root to get rid of a exponent of 7. Now on the calculator, it's a specific way of doing it. Same thing on Desmos. There's a function for it on Desmos. You can go to functions and scroll down, you'll see it. But in the meantime, I'm gonna press math and go to that little guy right there, 2187. That's not what I wanted. 7th root of 2187, and I get 3. That is my answer. However, if you want to go about it a little bit differently, and I think it's worth explaining here, let's do it again. Another way of solving this is by raising it. I love this. This is beautiful. Raise it to the reciprocal power. What? Okay. I took a 7th root to get rid of the 7. A 7th root is the same thing as raising it to the 1/7. I can do the same thing right here. So 7 and 1/7 cancel out. Because I'd multiply these powers, I'd have x to the 7 to the 1/7. 7 times the 7th is 1. So that gives me x to the 1. And then I can do the same thing here that I see on my paper. And I get a 3. Which really means, just to put this back in context and to make sure the problem works, log base 3 of 2187 is indeed 7. Ha-ha! Okay, I'd love to rearrange it, but don't. Let's do this one in our head. Please do this one in our head. 8 to what power is 64? How many 8s would I multiply together to get 64? Sometimes they're decimals. This one is not. There we go. I would square it. 8 squared. Okay. Do I rearrange this one? Okay, well, I don't have x by itself, so yes, let's do that. If x is by itself, don't rearrange it. Okay, 25 to the 1/2. Don't use the calculator if you don't want to. Actually, I'd rather you not at all. 25 to the 1/2 is the square root of 25. Square root of 25 is 5. Okay, don't do the plus or minus thing. If you do plus or minus here, you'll be taking the log of a negative number, and just don't, it's not going to work. Now, I do want to point out that it is possible to have a negative number as the result of a logarithm, because exponents can be negative, but you will never have a negative number here or here. It will never happen in this class. Okay, last problem we're going to do. First without a calculator, then with a calculator. I do have a logarithm. I'm going to rearrange it. Let's call it 10. There's an understood 10 there. So 10 to the 1/3 equals x. So without a calculator, you could stop here, or you could say this is really the cube root of 10. And you'd be happy and I'd be happy. But that is a decimal that I don't know. Nobody does off the top of their head. Well, I'd hate to say that. I'm sure somebody does. But it is irrational, so it goes on forever. So no one knows it fully. 2.154. There we go. By the way, if you checked your answer on this one, if you wanted to plug 2.154 in right there, you won't get 1/3. You'll get something super close to it. Let's do it. Log base 10, that was unnecessary. Let's take that out. Of 2.154, and get an error. Here, let's try it again. Log base 10, 2.154. There we go, 0.333, that's a third, but then the whole thing falls apart after that because of the rounding.